Good morning, everybody. So nobody has joined now also. So we will wait for a little bit time. So we will wait for 2 or 3 minutes so that rest of the student could join, and then we will start the class. Good morning, everybody. My voice is audible?
Yes, sir.
Okay, so we have already delayed the class. 5 minutes is already gone. Now let us start the class. So yesterday we have started our section convolution and we have done our section convolution. And in the section convolution, we discuss about the different types of section convolution. And on that, first we have discussed the overlap. Just a minute. We have discussed firstly the overlap add method and overlap same method. And overlap same method, we have done a numerical problem with the help of overlap same method. Today we will start overlap add method, and we will see that overlap same method and overlap add method gives you the same answer, as because they are same procedure. They are all they are doing the same thing. They are doing the convolution, section convolution, but the procedure are not same. There are two procedures to solve these equations, and the procedure or approach is different, nothing else. So let us start our today's section. In that we will start with the numerical problem that we have discussed yesterday, and we will try to solve it by the section convolution. So let us start the problem. So let us start with section convolution. So today is 25th. Overlap add method. The same, we have the same problem. Determine the output of a linear FIR filter whose impulse response. I'm again repeating the problem. Sorry. Determine the output of linear FIR filter whose impulse response is HN equals to 1, 2, 3, and input signal is Xn equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So the solution of this problem using overlap add method. Today we will use overlap add method. Last day we have solved it by overlap same method. Today we will solve it by overlap add method. So solution. So the given hello.
Yes, sir.
Yes, the given input data sequence is Xn equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the given input data sequence. Now we will divide the input data sequence into 3 data subblocks as the length of the impulse response is equal to m equals to 3. So we will divide the input data sequence into 3 data subblocks as the length of the impulse response is m equals to 3. So this is the first dividation of the input data sequence, that we will take three data sequence. Now, next step is add m minus 1, that is equals to 3 minus 1, that is equals to 2, zeros at the end of each data subblocks. At the end of each data subblocks. Okay. So that will be x of 1 of n equals to 1, 2, 3, 0, 0. So this is m minus 1 zeros. Next, x2n will be 4, 5, 6, 0, 0. So this is a minus 1 zeros. X3n will be 7, 8, 9, 0, 0. These are also m minus 1 zeros. So this is the difference here with the overlap add method, a overlap same method. What we do in the overlap same method, just a minute, I am giving you a previous day short. Share. Just a minute. So you can see here last day what we have done, we have in the overlap add method, same method, what we have done, you can see here, we have taken 3 data blocks, sub data block, and we add m-1 zeros, this m-1 zeros in the first sub data block. Okay, that means
Yes, sir.
before the data blocks, we add 2 zeros. But here we are adding zeros after the data blocks. So that is the basic difference first. And then what happens if you see it more precisely, just a minute. If you see it more precisely, yes, you can see here, we are getting the last previous data blocks m-1 values. Means from the last data blocks, last was what? Last was 2 and 3. So 2 and 3, we are getting these values. You can, if we little bit go to previous one, you will see these data blocks here. You can see here, the last 2 data blocks were what? 2 and 3. So that is repeated. That is repeated here. That is here. And again, the 3 new data blocks. So that is the process of overlap same process. But in overlap add, what we are doing, we are constantly adding m-1 zeros in the end of each data subblock. So there is no questioning of adding or doing previous data blocks into the sequence, new sequence. So just you write your 3 length new input data blocks and then add m-1 zeros. Again, write 3 new data blocks and then add m-1 zeros. Again, write 3 new data blocks and then m-1 zero. So like this, you will generate your new input sequence or new divide. You will divide your new input data sequence. Okay. Understand?
Yes, sir.
That is very important. That's why.
सर इसमें इसमें जो है जो इम्पल्स रिस्पॉन्स इम्पल्स वाला जो है उसमें मतलब डेटा जो रहेगा सर कम ही रहेगा उसके तुलना में जो इनपुट की तुलना में हमेशा।
हाँ, ज्यादातर क्योंकि इनपुट डाटा सीक्वेंस लॉन्ग होगा, सेक्शन कन्वोल्यूशन में इनपुट डाटा सीक्वेंस लॉन्ग होगा, इसीलिए इम्पल्स रिस्पॉन्स तो कम ही होगा हर बार। और इम्पल्स डाटा सीक्वेंस जितना लेंथ का होगा उसी हिसाब से आपको वो इनपुट डाटा सीक्वेंस को डिवाइड करना है, ठीक है?
यस।
Okay, so next, in order to perform circular convolution, the length of impulse response must be equal to the length of the data subblock. Therefore, how much length is there for impulse response? The length is 3. So if it must be equals to new input data subblock, then it will be added 2 zeros at the end. So the new impulse response, hence we can write the new impulse response h of n equals to 1, 2, 3, 0, 0 to match the length of the impulse response with the new generated data blocks. We are adding 2 zeros at the end, and this process is called zero padding. What is zero padding? If anybody will ask you the question, you will answer to match during convolution to match two sequences. If there is a mismatch in the two sequences, to match two sequences, if you add zeros at the end of the data blocks, then this process is called the zero padding. So we have to perform circular convolution. So first output y of 1n will be the circular convolution of x1n. This is the notation for circular convolution. Okay, n over that round. That means you are doing circular convolution. Where normal convolution is x1 asterisk hn. That will be normal convolution or linear convolution. And circular convolution is this type. Okay. So the notation between the circular convolution and the linear convolution, you must give an idea. So this is linear convolution. And this is circular. So this is the notation. So note. So x1n is then circular convolution with h of n. Next y to n will be nothing but x to n circular convolution with h of n. And y3n is nothing but x3n, that is circular convolution with h of n. So you know how to do the circular convolution in matrix method. So I am not going to tell you the circular convolution method again in this class because it is the longest process. So okay. So after doing the circular convolution, we get the results after the circular convolution. We get, I'm omitting the circular convolution, you can do it at home, but you have to do it in the examination time. Y of 1n equals to 1, 4, 10, 12, 9. Y to n equals to 4, 13, 28, 27, 18. Y3n equals to 7, 22, 46, 42, 27. So these are the values. Now again we will draw some blocks like we have drawn yesterday. So first block, this will be 1, this will be 4, this will be 10, this will be 12, this will be 9. So again under blocks, So this will be 1 bit, this will be 2 bit, this will be 3rd bit, this will be 4th bit, this will be 5th bit. Again, another block, under. So this will be 1st bit, this will be the 2nd bit, this is the 3rd bit, this is the 4th bit, and this is the 5th bit. So 1, 4, 10, 12, 9. Next is 4, 13, 28, 27, 18. Next is 7, 22, 46, 42, 27. So this is Y1N. This is Y2N. And this is Y3N. Now, if we talk about overlap same method that we have done yesterday, if we talk about overlap same method that we have done yesterday, we have also drawn like this block. So what is the difference of that and this? Just look at that. You can see here, we also placed here the values. You can see here, we also placed here these values. There is also the blocks. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So there is also the blocks. But what is the difference is that what we have done discard first m-1 points from each data blocks. From each data blocks, we have discard m-1 points. That means 2 points. M is 3. So 3 minus 1, that is 2 points. So I will discard the m-1 points from each data blocks when we will do overlap same method. Same means minus. So we will minus each m-1 points from each data blocks. First two data blocks. First two data of the each data blocks. Understand? But here what we will do, here we will add. That's why it is named as add. Add two data blocks, last two data blocks from with the first one. That means these two will be added with that two. M-1 data blocks, data points. Same here, these two will be added. So what will be the answer now? Y of n will be equals to 1, 4, 10, 16, 22, 28, 34, 40, 46, 42, 27. Let us see, is this answer and that answer is same or not? You can see here 1, 4, 10, 16, 22, 28, 34, 40, 46, 42, 27. So 1, 4, 10, 16, 22, 28, 34, 40, 46, 42, 46. 7. So this is the answer. Understand?
Yes, sir.
Overlap add method and overlap sub method. These are the two methods by which you can do section convolution. If you want to verify that your answer is right or not, then you can again do that linear convolution portion. If you do the linear convolution portion, you will see that the same answer is coming. So matrix method, linear convolution, this is only for verification. You cannot do this in examination. This is only for verification that your answer is right or not. For verification, we can do, but if you do this thing in section convolution, you will not get any marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, these are the 3 bits. So again, 1, 2, 3, 2, 4, 6, 3, 6, 9, 4, 8, 12, 5, 10, 15, 6, 12, 18, 7, 14, 21, 8, 16, 24. And the last is 9, 8, 27. So again, we will divide it diagonally. So by diagonally, if you get, you will get y of n equals to say 1, 4, 10, 16, 22, 28, 34, 40, 46, 42, and 26. So this answer and this answer is. So that is the verification. This is only the verification. So hope everybody has understand.
Yes, sir.
Overlap add and overlap sub method. So this question will
Yes, sir.
any one of the overlap add and overlap sub method will come into your examination. So that is the aim of our convolution. That is the next first module. Next, we will go, if I see our syllabus, then we will go to our next part. That is, I am sharing you the syllabus just a moment.
सर हेलो सर बोल रहे हैं कि डॉक्यूमेंट सब अपलोड कर दीजिएगा ना गूगल क्लासरूम में नोट्स वगैरह
थोड़ा किया हुआ
अपलोड
है,
नहीं किए
थोड़ा किया हुआ है,
हाँ
थोड़ा
सर बहुत दिन से नहीं हुआ है
हाँ बहुत दिन से नहीं दिया
यस
हुआ
सर
है।
यस सर
यहाँ पर कॉलेज बंद है, वर्क फ्रॉम होम हो रहा है, इसीलिए नेट का थोड़ा प्रॉब्लम हो रहा है, इसीलिए थोड़ा प्रॉब्लम हुआ था। ठीक है, फिर मैं इस वीक में दे दूंगा। ठीक है,
यस सर। ओके सर।
where is the syllabus? Just a minute. Just a second. Let me bring up the syllabus. So just wait for 2 minutes. I'm searching the syllabus. Just a minute. Yes, I have got the syllabus. Now I can share it. हाँ, सभी लोग अपना वो अटेंडेंस थोड़ा दे दो, जैसे कि सावध ने दिया है, सादब ने दिया है, वैसे चैट बॉक्स में हर एक अपना अटेंडेंस थोड़ा दे दो। तब तक मैं आप लोगों को वो दिखा रहा हूँ। बाद बाकी अपना अटेंडेंस दे दो जल्दी जल्दी। अटेंडेंस नहीं हुआ। चार, सिर्फ 4 आदमी का अटेंडेंस हुआ है। 3 और 1 4, अभी भी अटेंडेंस बाकी है कुछ कुछ का। ठीक है, छोड़ दीजिए, जो जो देना चाहता है दे दीजिए, वरना खत्म कर दीजिए। तो अभी तक जो कन्वोल्यूशन का चैप्टर मैंने पढ़ाया है, वहां पर अगर किसी को कुछ प्रॉब्लम है तो बता सकते हैं। आप लोगों को कोई प्रॉब्लम है, डाउट भी हो तो बता सकते हो आप लोग।
नहीं सर। सर डायरेक्ट डिजिटल सिग्नल प्रोसेसिंग लिख दीजिए, आ जाएगा, मैच हो जाएगा सर्च होने पर।
हाँ, आई थिंक चला आया है, थोड़ा प्रॉब्लम था, मैं थोड़ा एक काम कर रहा था इसलिए भी नहीं देख पाया। ये लो 711 चला है, 712 चला है, तो 713 चला है, ये हो गया अपना। तो LTI सिस्टम कंप्लीट हो गया, डिस्क्रीट टाइम सिस्टम कंप्लीट हो गया, डिस्क्रीट फूरियर ट्रांसफॉर्म अभी है, डिस्क्रीट टाइम फूरियर ट्रांसफॉर्म अभी है, फास्ट फूरियर ट्रांसफॉर्म अभी है, मतलब फूरियर का पूरा पोर्शन बाकी है और जेड ट्रांसफॉर्म बाकी है। यही दो बड़ा चैप्टर्स बाकी है। फिल्टर डिजाइन तो आसान है, वो तो नोट भी दे सकते हैं, तो प्रॉब्लम न्यूमेरिकल प्रॉब्लम सब सॉल्व कर सकते हैं। आपको पहले, इसके पहले कोई सिग्नल सिस्टम या किसी किसी क्लास हुआ है? क्योंकि जैसे कि फूरियर ट्रांसफॉर्म के
हाँ,